Hello, and thank you for viewing this Ashford University Teaching and Learning Conference Discovery session. I'm Jeanne, Perrone, a graduate student at Ashford, earning the Master's of Science in Instructional Design and Technology, where a focus of the program is the completion of an authentic instructional design project. I have been working as a veterinary nurse for 27 years, and my field specialty is dentistry. I have been a trainer for 12 years in dental radiology. My project uses my background as a trainer in veterinary dental radiology. This discovery session introduces you to my training project that uses the InterPLAY model as an instructional strategy design. This discovery session presents my design of a training intervention in dental radiography for veterinary medical staff. Based on experiential learning found in the InterPLAY model, the intervention achieves the training goals by framing and activating the experience while giving the participant time to reach a deeper understanding of the process that leads to improved retention of the material. After listening to this discovery session, you will be able to, 1, recognize how the InterPLAY model can inform experiential learning designs, and 2, evaluate the role of the InterPLAY model for your instructional strategy design needs. Will an experience-driven understanding create more competent practitioners? Yes. The experiential learning that is the foundation of instructional strategies designed using the InterPLAY model achieves training goals by framing the learning experience in a real or nearly authentic context to activate learners' existing experiences, to create a deeper and more lasting understanding of their learning. This experience that drives understanding is known from decades of research in the field of instructional design and technology to improve retention of the material. Experience-driven understanding also is known to promote transfer of learning to new contexts in a variety of professional practice areas and was therefore very relevant as a choice. Each learning objective needs a type of content and strategy that would present the material effectively to allow the participant to demonstrate the task correctly. In the chapter on instructional strategies in the book Designing Effective Instruction by Gary Morrison, strategies are developed using prescriptions. Prescriptions are aligned with each outcome. Prescriptions are created to achieve the intended performance of the participant using the planned materials. The prescriptions used to develop instructional strategies are fact, concept, principle, procedure, interpersonal skill, and attitude. For this project, the prescription for procedures best suits the content and the learning objectives. Procedures are a predetermined list of steps that the participant follows to complete a task. The generative strategy occurs in 2 steps. The first step is the development of a mental model to review the steps of the exercise for the participant. The review of the steps can be presented in multiple ways, such as providing a written list or multimedia demonstration of the steps. The second step is a practice session where the participant performs the steps of the task. Over the next several slides, you'll hear about how InterPLAY was used as the framework for instructional strategies to teach veterinary dental radiography and be able to evaluate how this model might be useful in your instructional design and learning experiences, as well as for any students listening to this session. Performance analysis results. An instructional intervention is needed. An extensive needs analysis with the stakeholders helped to identify the underlying performance changes needed that could be addressed with an instructional intervention. A task analysis was conducted that revealed 3 areas for focus in the training's design. A subsequent performance analysis revealed a lack of success in clinical environments on 3 key task areas. Demonstrating correct placement of the sensor. Inadequacies in identifying anatomy and lack of attention will cause the participant to position the sensor in the mouth incorrectly. The performance issues stem from inadequate knowledge of anatomy or lack of attention during the training demonstration. Demonstrating correct angulation of the tube head. Incorrect angulation of the tube head will result in a non-diagnostic radiograph due to the tooth image being elongated or foreshortened. The challenge is translating a simplified positioning concept to hands-on training and subsequent mastery. Identifying solutions to errors found on the finished dental radiograph. Participants become frustrated when they must repeat x-rays. Focusing a portion of the training on identifying errors improves problem-solving skills. Correctly solving the cause of the error will diminish the need to perform repeat x-rays. We'll spend a little time looking at how the learner characteristics made the InterPLAY model an ideal choice for the designing of the instructional strategies. Participants for whom this instructional design project is geared come from a veterinary clinic. Veterinary clinics tend to hire people that are not medically trained and train them in-house. Clinic-trained staff are not required to obtain continuing education except that which may be required or provided by the clinic. If a training is required, attendance is mandatory. If the staff member is interested in the training, motivation is high. And if they are not interested in the training, motivation naturally can be low. High motivation can also be seen if completion of the training improves their standing in the clinic. Medically trained nurses, and I mean veterinary nurses, can also experience the same variances of motivation. If the nurse rallied the clinic to make improvements to their dental service, motivation is high. Sometimes nurses who feel they have accomplished the dental radiology skills needed for the upcoming training may feel it is a waste of time. So demonstrating the impact of ineffective practice by evoking the emotional connection to the importance of effective radiographic practice is obviously necessary as a component of the instructional design. Learner characteristics. Beyond the variations in education levels and motivations stemming from that, the learners in this design are known to vary in ages as well. The graph on the screen shows that the learner analysis revealed a majority of the training participants will be in the 21 to 30-year-old range. After doing some research on generational differences, this explained some of the lack of success the participants were having. 21 to 30-year-olds are categorized as millennials, sometimes called Generation Y, and known to be eager to learn, but become frustrated if the knowledge does not have immediate relevance, making it useful to swift application. As Stapleton and Hirumi stated in their 2014 publication about the InterPLAY model called Designing the InterPLAY Learning Landscapes to Evoke Emotions, Spark the Imagination, and Promote Creative Problem Solving, humans of all ages tend to learn more effectively when they experience instructions with relevant, meaningful, and interesting goals, and when they are developing skills and acquiring knowledge of facts, concepts, procedures, and principles in context. How will they be used? The identified instructional needs were further analyzed in a task analysis revealing specific instructional needs, such as how the angle of the X-ray machine affects the length of the tooth, evaluation of the radiographic results, and the ability to make adjustments to the angle of the tube head, and lastly, the location of the sensor to improve the image. The three conditions became the basis of the learning objectives for the training design, which then suggested experiential learning was the ideal focus for selecting the InterPLAY model. for design of the instructional strategies and their supporting materials. Figure 1, from the 2014 publication by Stapleton and Hirumi, Designing Interplay Learning in Landscapes to Evoke Emotion, Spark the Imagination, and Promote Creative Problem Solving, shows the key conventions and elements of the interplay instructional theory. The interplay model demonstrates that learning is best achieved when instruction is coupled with active learning. The participant activates the experience using live simulations or games in a play-based environment that stimulates or emulates real-world conditions. For this design project, live demonstrations by the trainer are performed on dental models. The participant repeats the demonstration on the dental model and then reflects on their outcome of their practice based on their assessment results and considering the impact of effective and ineffective skill sets for the patient. Better outcomes are expected to be achieved as a result of the participants mentally working through each step of the task and analyzing their own results with repetition of steps and recall and reflex cycles included for deepened learning. Use of live demonstrations and discussion of impacts help to evoke emotion in the learner about the impact of what they are learning and foster a deeper transfer and mastery of learning in the eventually real-life implementation of learning from the instructional strategies. Learning is a neurobiological function, which causes us to process information as we learn. That information processing represents experiential learning. The neurobiological function provides the foundation for the interplay design model. InterPLAY is an instructional model that integrates universal principles of experiential learning and again includes elements of story, play, and game seen in the slide. Each one of these elements integrates with the experiential learning principles. Story can be represented through characters, worlds, and events. Play can be represented through stimulus, response, and consequences. Game represented through goals, rules, and tools. This integration sparks the imagination, evokes emotion, and creates a deeper learning experience. 6 instructional events, listed down the middle of this figure, are used in part or as a whole to facilitate the learning environment. As you will see in the upcoming slides, the learning objectives will utilize these events to enhance the performance outcome. Drawing on the interplay model as my guide, instruction was designed to embody the following performance outcomes. Each learning outcome on the left is paired with a performance outcome on the right. These outcomes will be assessed and measured during the training. If the participant is able to connect the objectives and the performance outcomes, they will achieve a deeper understanding of the process and better retain the skill set. Our next 3 slides will look at a portion of the performance outcomes to show you how the interplay events are utilized. This chart shows an example of how the interplay instructional strategies are used to improve performance success for the participant. The interplay instructional strategy works best in this project because of the tactile and physical nature of the tasks that need to be learned. The explanation box down here at the bottom shares what the trainer will be demonstrating and what the learner/participant, I use participant in my study here, will need to perform. Over the next 3 slides, let's examine the integration of the interplay instructional strategy with each performance outcome. Expose. The trainer exposes the task by identifying the oral anatomy structures that need to be radiographed to the participant by performing a demonstration. The participant recalls each of the steps which will establish the knowledge base, which is the foundation for each skill. This sets up the desire to learn and stimulates curiosity. Inquire. This strategy validates the success of the demonstration. The participant must make a mental picture of the location of the oral structure that needs to be radiographed. The participant asks questions if there are challenges in understanding. The demonstration will stimulate the participant's curiosity by setting up an activity for them to do. Create. Interactive engagement with the subject. This interaction stimulates the participant with physical engagement with the dental X-ray equipment and the model. The trainer provides feedback on the participant performance. Experiment. How do we measure success? It is more than being right or wrong. The trainer will request the participant to point to the requested location to be radiographed. The participant assesses the results of their attempt at identifying the requested location. The participant must integrate the problem-solving skills and assess their performance. If there are difficulties, how are they resolved? Mistakes can be valuable feedback and cause the participant to think outside the box and choose alternative approaches. Our next slide, the performance outcome is the participant will effectively position the plate in the dental model. Expose. The trainer exposes the task by demonstrating where the sensor plate needs to be positioned for the radiograph. The participant recalls each of the steps which will establish the knowledge base, which is the foundation for each skill. This sets up the desire to learn and stimulates curiosity. Inquire. This strategy validates the success of the demonstration. The participant must develop a mental image of how to position the sensor in the mouth in the correct location. The participant asks questions if there are challenges in understanding. The demonstration will stimulate the participant's curiosity by setting up an activity for them to do. Discover. Problem-solving techniques. Potential challenges within the task are reviewed along with how to resolve challenge. Common challenges can be, for example, how to work around the tongue or the endotracheal tube, which usually delivers the anesthesia to the patient. Very important. Create. Interactive engagement with the subject matter. This interaction stimulates the participant with physical engagement with the dental X-ray equipment, specifically the sensor plate. The trainer provides feedback on the participant performance. Experiment. How do we measure success? The participant assesses their attempt at placing the sensor in the dental model. The participant must integrate problem-solving skills and assess their performance. If there are difficulties, how are they resolved? Mistakes can provide valuable feedback and cause the participant to think outside the box and choose alternative approaches. Given a specific oral location to radiograph, this participant will select the correct angle using the protractor on the tube head. The participant will align the tube head over the sensor. Expose. The trainer exposes the task by identifying the oral anatomy structures that need to be radiographed to the participant using demonstration. The participant recalls each of the steps which will establish the knowledge base, which is the foundation for each skill. This again sets up the desire to learn and stimulates curiosity. Inquire. The strategy validates the success of the demonstration by developing a mental image of how to manipulate the tube head using the protractor on the side of the tube head and then aligning it to the sensor in the dental model. The participant asks questions and and in there are challenges in understanding. The demonstration will stimulate participants' curiosity by setting up an activity for them to do. Discover problem-solving techniques. Potential challenges within the task are reviewed along with how to resolve the challenge. Common challenges are sensor movement, the protractor being read incorrectly, or the alignment over the sensor is incorrect. Create interactive engagement with the subject matter. This interaction stimulates the participant with physical engagement with the dental X-ray equipment and the dental model. The trainer provides feedback on the participant performance. Experiment. How do we measure success? The radiograph is taken and the resulting image is reviewed. There are additional questions to consider. What constitutes a successful image? What do technique errors look like? The participant assesses the results of their attempt at taking a dental X-ray. The participant must integrate the problem-solving skills and assess the image. If there are technique errors, how are they resolved? Mistakes, again, can provide valuable feedback and cause the participant to think outside the box and choose alternative approaches. Instructional plan. Now let's take a quick look at how these outcomes are reflected in the broader instructional plan. Goals. The goal is to have instructional content that enables the participant to navigate through each of the learning objectives. Each piece of content provides active learning opportunities. Active learning builds experience for the participant to ensure retention of the skill. Session materials. As I mentioned earlier, the course is divided into 3 sections, with instructional materials appropriate to the subject. The materials will be discussed later in this presentation. Online training. The online training focuses on preparation. This portion of the training will be delivered through an asynchronous learning platform. The participant must complete the online session before moving to the active session. The course has 4 units. The units cover oral anatomy, examining the oral cavity using a patient dental record, an overview of the dental X-ray equipment, and radiation safety. Each unit has an assessment, and the participant will have a chance for feedback at course completion. Face-to-face training. The face-to-face training provides skill building through interaction with the course materials and the trainer. The course has 5 units that following the course objective. Each objective has performance outcomes that will be assessed using rubrics, direct testing, and anecdotal records. This will be expanded upon later in this presentation. Post-training. Post-training gives the trainers time to provide feedback about the participant's performance. Participants will also give feedback about their experience with the face-to-face training session. Now let's look at how the instructional plan and needs for the application of the InterPLAY model for strategy design inform the instructional materials design and development. The online session will be presented through an asynchronous e-learning platform. Video presentations and demonstrations in the online portion provide orientation to the steps of the procedure that will be performed during the face-to-face training. The session will be taught by a trainer using demonstration models. Demonstration models are defined as skulls or lab specimens. The specimens provide a more realistic experience during participant interaction. Demonstration equipment is defined as the X-ray generator, digital X-ray sensor plate with corresponding software. The equipment training orients the participants on safe and proper use. The future of training medical skills is in the addition of virtual 3D simulations. This would be in addition to or in place of demonstration models. For continuing education, this will be a great tool for follow-up with participants after training is completed. Questions could be answered and skills reviewed. Orientation using 3D simulation could be done as part of the online session as well. This is a table that expands to show the connection of the learning experience with the assessment. The instructional strategies for InterPLAY, expose, inquire, discover, create, experiment, share, are now aligned with each one of the performance outcomes, as you can see, and as we have gone over earlier in the presentation. The assessments that will be used to measure the progress and success of the participants is also aligned with the learning outcomes. Assessments will be carried out using direct testing with rubrics to monitor participant performance and assess their success after each performance outcome. Summative assessments will also allow for the participants to be assessed and provide feedback throughout the process and after the training is complete. The results of the assessments and the feedback will be used to find further training gaps and provide data into the necessity of a follow-up training where participants could troubleshoot problems and ask questions. This concludes the discovery session, and I want to offer a special thanks to Dr. Lisa Johnson, MSIDT Assistant Professor, for her assistance in finalizing this presentation's design and scope, as well as to Dr. Thomas Atkinson and Dr. Tusi Hirumi for their insights into its development as well. Please send questions to me about this presentation and share your ideas for use of InterPLAY to guide your designs of experiential learning to my student email at jeanne.perrone@student.ashford.edu. And thank you.